Okay, so midterm is going to be on Monday. It's going to cover up through everything we've done so far. Okay, so basically up through chapter 17, I guess it is, stacks and cubes. Okay, so I'm going to go through, hit some of the highlights, things you should know, and then if there's time, I'm going to work through the palindrome problem because some people may have had some trouble with that one. Okay. Um, Before I get started, midterm grades are out. Um, if you have work you can still do when you were sick, make sure you talk to me. We get a plan together to get that made up as quickly as possible. Um, Things are getting tougher. Okay. If not, if you have questions as to why the grade is the way it is, let me know. Your grade should be a little higher than it is on Canvas because I have reduced the importance of quizzes because we haven't had enough yet. And I've also dropped, in essence, one program score. So I gave everybody else 10 extra points on their programming stuff. Okay. So that should lead to a little higher score. If your grade is lower than it is in Canvas, then let me know because maybe I messed something up. Okay. It does happen. Okay. So the exam. So first, there's stuff that just I assume that you know coming in from C++. Okay, all the basic things on how to create variables, how to do global variables, how to do loops, how to do all that stuff. Okay, create functions. All of that is assumed, and maybe in any of the problems or any of the questions. There's no programming on the test. It's going to be on paper, so I'm not going to say create this giant program. I may say create a function. I may say create an algorithm. Okay, but no actual code. Okay. The things that you do want to make sure that you're solid on, because we've been using them a lot lately and sometimes in different ways. The whole idea of classes. Okay. When do you need a class? When do you not need a class? How you can create the classes. Um, Inheritance. As part of inheritance, we've talked about the abstract data type. Okay. So an abstract data type, good examples are the stack and the queue. We're going to see them again. Okay. It's where you want to have consistent behavior, but you want to allow some options on how it gets implemented. Okay. So, for example, I was talking to Cameron right before class. The program that you do, or program that you use the linked queue for, you should be able to switch to the queue type, and your program should still work. Right? It's independent because they both implement the abstract data type. Okay. So as part of that, we also talked about virtual functions and pure virtual functions. Those are important. Again, it's important to know what that means, not just how to create one. So what is a pure virtual function? A pure virtual function, that's what makes an abstract class abstract. And that means you can't create an object of that type. Okay. And what the pure virtual function does, it's just the prototype or the signature of the function. It's not the whole function. Okay. It creates an obligation in any file that inherits from that ADT. Okay, so the is full queue that's in the QADT, if you're going to extend the QADT, you have to include an is full function that takes no parameters and returns a Boolean. Okay, it's an obligation. Okay, and that's again to enforce the behavior. So if at some point down the line you've written a program using array-based queues, well, now you want to switch because you've got a memory problem. You want to switch to the linked list-based queues. You should be able to do that transparently with no trouble at all. Okay. So we also talked about overloading functions. Again, I've said it before, but it's important to say it again. Whenever you have a class that contains memory data or memory constructs in the memory data, that can be an array, it can be a pointer to a node, whatever it is. Okay. You then have some obligations, and those obligations include you have to, it's all about avoiding aliasing. Okay, so aliasing, again, just to review, is when you have two names for the same physical object. That's a bad idea. Okay, so those things you have to do, you have to overload the assignment operator, the equal sign. We've seen that in the linked list and the array versions of stacks and queues. Okay, you also have to create a copy constructor, again to avoid aliasing, and you have to create a destructor to get rid of the memory that you've allocated. Okay, so those three things have to be there. It's important that you know that. Okay? We've also talked about templating. The simple examples we did were all ints, but the things from the book we're all using the templating where you have where you can use different types. So the type becomes a variable for the type of the variables you want it to be, okay? And in the palindrome, we used a queue of strings and a stack of strings, okay? Exception handling will not be big on the exam, but you should know what it is. Again, that's with the try block. Well-designed program should never just seg fault. I'm looking at you there, Cameron. They should never just seg fault. They should never just blow up. So by using the exceptions, which we haven't done enough of because we've been trying to cover other things, but it's important to understand that you have to handle the exception, either a generic exception or maybe an actual, if you know what the exception is going to be, like a file not found or whatever. It's important that you handle this, okay? And we're not doing a great job about that, but we should be, okay? And then we talked about recursion. We haven't seen recursion a lot yet, but we have a little bit. So we'll see it some more, okay? So just the idea, recursion means it's a function that calls itself, and that the basic parts of recursion are you have some base case, you have to know when you're done, and then you have the recursive step where you call the function with a diminished version of the problem, okay? So the whole idea behind a recursive algorithm is that you can reduce the problem and call the function with a reduced set of it, okay? So yeah, lots of stuff about that, okay? And then we hit what really is going to be most important on this exam. All those are possible questions or parts of other questions. But the big thing for this test are going to be linked lists, stacks, and queues, okay? So the linked lists are the first real data structure that we've created, okay? And for all of these, we've done assignments, and you got to make sure that you're clear on this, that there are times when we're creating the data structure itself. So anytime we're adding functions to the linked stack type or the linked queue type, okay, that's creating the data structure that we tested. Then there are other programs like the palindrome program where we're just using that, okay? If you're using the data type or the data structure, you don't have to create it again, okay? You're just going to pull it in, and that's going to be it. Hopefully we'll have some time, I think we will, to get to the palindrome program, see if we can work that one out, okay? Linked list, again, they come in some varieties, and you have lots of options there. You can have it where you can add to the front of a linked list, you can add to the end of a linked list, you can delete from the linked list either any position based on its value, okay? The linked list can be a doubly linked list. That's when it goes there's not only a next, but there's a previous, okay? So you can go back and forth if you want to. You can have a circular linked list that once it goes to the end, just comes back to the beginning, okay? With a circular linked list, your concern is losing where the front one is. So when you're iterating, you just don't go through forever, okay? And that's the basics of linked lists. If you have questions, we'll open that up in a second for that, okay? Again, we're always going to compare, and you're going to see a question about this, I can almost guarantee, comparing linked list to arrays, okay? So arrays give us everything, right? And that they give us total access to every single element anytime we want. We can go right to the middle, right to the end, anywhere, okay? So it's a valid question. Why not just use that? Well, and the reason why, as we talked before, arrays require that you allocate contiguous memory in advance. And if you don't get it right, you either waste memory or you don't have enough and you run out, okay? Also, the reason for, especially with the stacks and the queues, they're very particular in how they allow you to access data. If the problem you're trying to solve needs that limit, then by using a stack or a queue, you don't have to enforce that behavior yourself. Okay, so it's just a way to conceptualize the problem and then to not have to write all that code to keep the user from doing things. Okay. Stacks in, the big idea, they're the last in, first out. Okay, so the stacks are going to reverse things. Okay. Stacks can be implemented with arrays, which they have all the same memory problems that arrays have. Okay, or they can be implemented with linked lists. We did both of those. Okay. Queues are the opposite. They're first in, first out. Okay. So queues do not reverse anything. Queues maintain the same order. Okay. So anytime you need to keep track of jobs or whatever you're keeping track of, that's when the queue is going to come in handy. Okay. Again, those can also be implemented either with arrays or with linked lists, okay? One other thing that could be on the test, there's a problem with queues and arrays. The problem being that because you're adding to one end, the right side of the array basically, and removing from the left side, every time you do a delete queue, you've diminished the capacity of your of the queue, right? You can't get that first element back, okay? So the way to fix that, or the easiest way to fix that, is to use a circular queue. So when you go off the right-hand side of the queue, as long as there's room, you can go back and get to that front part of the queue, okay? And that involved basically using the modulo operator on the max queue size on both the add and the delete to reset those values, okay? So that's it. That's all the material as far as what is going to be on the exam, okay? Again, the format could be, it could be asking you for an algorithm. How do I delete something from a linked list, okay? Or you'd have to give me the general idea in code, like you could probably even do code and it would be okay. But just explain kind of how that works. Not the whole thing, but how that particular thing works, okay? I could ask you to draw a diagram that shows the position of whatever pointers you have when you go to delete something. Do it visually, okay? Same thing with stacks and with queues, okay? I could ask you to talk about, again, what's the problem with using an array for a queue? And you would have to know about the hole and how to fix it and all that stuff. Okay? So those are the kinds of questions that I'm looking for, okay? Something I did, which I encourage you to do, I went to our friend ChatGPT and asked it to create a study guide for me for a midterm that I was going to have covering linked list stacks and queues. I did a pretty decent job. You can do the same thing. So basically on the linked list, it gave us the key concepts here. Compare and contrast linked lists with arrays, explains the type of linked list, singly, doubly, circular, and their use cases, discuss the memory management benefits and drawbacks of linked lists. Even gives you some, because I said it was going to be an essay test, some potential essay questions. Explain the advantages and disadvantages of using a linked list over an array. Included discussion of dynamic memory allocation. How would you design an algorithm to insert a node in the middle of a single linked list? Discuss the steps involved. Those are decent questions, right? And it does the same thing for stacks and for queues. Okay, then there's a section on comparing data structures, compare and contrast stacks and queues in terms of use cases and efficiency, discuss scenarios where a linked list implementation is better than a stack or a queue, and then a potential essay question, in what situations would a queue be a better data structure than a stack and vice versa, and provide specific examples. Okay? So again, there's some good stuff there, okay? And then it talks about some real world cases that we could use for stacks and queues and all that stuff, okay? And then some study tips here. Focus on the concepts, okay? For essay questions, your ability to clearly explain and differentiate data structures is crucial. Practice writing clear, concise explanations. Relate to code. Even though the exam is conceptual, link your answers to implementation when possible. Describe how specific C++ operation would be performed. And then examples matter. When describing a data structure's operational advantages, use examples to illustrate your point. Okay? And then time management. So I'd said it would be about half-page essays, which is what the test will be. They should be structured with a brief introduction, clear explanation, and a conclusion. Ensure you address all parts of the question. It's like I wrote that. I mean, I didn't, but it may have stolen from me. ChatGPT does that. But those are the things that you need to worry about on the exam, right? You need to be able to explain the concepts quickly, give an example, why you would use it, and get out, okay? So what questions do you have about any of this stuff? What's tricking you up?
Some of the overloaded stuff.
Okay, so when you overload a function, the thing to keep in mind, you're doing a symbol, right? You wouldn't have to do it. You could just write a regular function. But let's say we're going to override the plus for some object we're creating. We then would have to say object1 dot add object2, which seems foreign, okay? So the operator overloading allows us to say object1 plus object2, okay? And they're always going to have the form of the one that calls it is the object1, and then what you set as a parameter is the object2, okay? And then you just, what's going to happen when you do that? Again, ChatGPT is your friend. Go there and ask it. Give me some examples of operator overload, or write me a tutorial, or create a sample test where you ask me questions and I'll give you answers. And it'll grade you for it. It's a great study aid. Other questions? Okay, then let's look at this palindrome problem. See if we can, I haven't looked at it yet, so we gotta, again, play fun with me figuring out all my typos. I did go ahead and what I always forget, I don't know why I always forget, but maybe you do too. I'd ask you on the problem that you're going to enter a string, and I said it was okay, but not optimal. Standing there to not allow spaces. So that would be the normal CN. Okay, if you want to allow spaces, then you have to use the get line with the CN and the input. Okay, so we can go ahead and do that from here. So let's go ahead. I hope I have those directories. Let's see if I have that in the right directory. So I don't have. Let's see. Do I have any of the stack and queues? There may be in the other directory. I can just pop it from. I should be okay. Let's see if this works. So if I want to include. I should be able to include it right from that directory. Okay, so let me just run this, compile and make sure it works. Yeah, that's okay. Seems happy. Okay. So the main point of this program, then, we're going to have some. Okay, enter a phrase. Okay, so we're going to get, and I would go ahead. I mean, they were doing it too, but I'm going to go ahead and print this out just to make sure this is working. If this is not working, nothing else is going to work. Okay. Not hell there, hello there. Okay, looks like we're good. That's our string, okay? So the next thing we're gonna have to do, I'm gonna have, I don't know if it said to do functions or not. You don't have to, so I'm not going to. I need to have a stack and a queue.
I think you had us do functions, but you might have,
Yeah, I don't know, I don't remember.
because I think does it have you have the stack queue type and the.
Yeah,
You have the
you have
stuff in
both.
there to add it.
Yeah, so if you're gonna do, functions and you're gonna make the global, you have to create stack type string S. Hopefully that's the right syntax. Q type string Q. Okay. See if that blows up. Does not. Life's good.
Will this show up on the?
Oh, I didn't share. Thank you for telling me that. I don't know what it's asking me, so I'm going to say yes. No. I can't pick what I want to share. That's very strange. Oh, if I do entire, okay. There we got it. Okay. So I can't see that, but maybe I can get over there. Okay. Okay, so let me take a look at this again and see where we're at. Okay, so what I've done here, it's this get line that allows me to get everything, including spaces. Okay. And then I'm including the stack type H and the queue type H. And then in the global setting, I'm creating a stack and a queue. Okay. So what I want to do, let me think how I'm going to do this as a function, because I'm going to need to iterate through the string one by one, okay, character by character. Okay. So when I do that, I have to add it. I'm not going to use functions. If I told you to, then that's just weird. Oh, that I can
Yeah,
do.
I would have to pull it up and I don't have access.
Yeah, because it's kind of a weird thing to do functions on. So I don't really need that. So let me get rid of that. Okay. So I'm gonna need a character. Okay, so I'm gonna have to say for int I equals 0. I is less than, how do I do a length of a string? Is it string dot length?
It's dot size.
Dot size. Like that?
Mhm.
Okay, so hopefully this is going to take me through character by
You
character.
have to include something.
I don't think so. I can include string. I already am including string. I don't know that I have to. String's weird. Sometimes you need it, sometimes you don't. So I should be able to say cout input sub I, right? I've got that correct. Yeah, okay. So now we're iterating through the string properly, okay? Which means that at each step, so the basic idea here, so I don't have to do this anymore. Let's get rid of that actually. So the idea here is that we're going to add each char. Oh, which means that my array is not of strings, it's of chars, right? To both stack and queue, okay? Which means I have to make these chars. Okay. So to do that, I can do an s dot push input I. See, when Emacs doesn't space like you want, you've left something out. And then a q dot add q input I. Okay. See, this blows up. If not, no error there. Still good. Okay. So when I get to this point, I should have a stack, okay, and a queue. So the first thing I can just check here, I can cout on the stack, the top, okay, and then I can cout the queue front. Okay. I do race car, which is a palindrome, by the way. Then I get an R for both. Okay. But that didn't tell me much. So let's do something different. Let's do hello, which gives me an O, right? That's correct on the stack. The last thing I put was an O, and the H looks okay. Looks like we're okay. Okay. So now the next thing that we need to do, once we've done this, okay. So we've tested that and we're good. So now we need to check to make sure the stack and queue are the same as we iterate through. Okay. And again, the key idea here is that the stack will reverse the string. While the queue will keep it in the same order. Okay, that's the idea. Okay. So I'm going to have to do some loop here, okay, for some number of times. And I can do the same loop I did before, in that I'm going to do it this many times, right? So I'm just going to copy and paste this. I think that should matter. It should be exactly the same thing. Okay. So each time through, I'm going to have to check to see if S dot top is equal to Q dot front. Okay, I've got to be careful here to know when I'm done. Okay, so if this is true, this is why we may have done this as a function, because this would be better in a function. But we can figure it out. Okay, so I'm going to go through. If they're the same, life's good. We don't have to do anything except do an S dot pop and a Q dot delete Q. Okay, that's going to move us through. Okay, else we're going to do something. We're going to see out that not, is it PALIN or EN?
I think it's iron.
Drone, right? Is that right? Doesn't matter.
Let me check.
Okay,
Yeah,
so
it's iron.
the issue here is that I need to stop it when this is the
Also,
case.
so you need to check if it's lowercase or not.
Oh, I'm not messing with that. Yeah, you're correct. The program should do it. I'm just gonna, yeah, that's a good point. For brevity, I'm not gonna do that. But yeah, inside of this loop here, we would want to make sure that the input is that the loop I want? No, this one. We have to check if it's lowercase. Make sure it's lowercase. Yeah, I didn't do that, but you should. Okay. Okay, so when I'm done here, this is my question. How do I know that I didn't ever hit this? This seems like a bad idea, but I'm gonna do it anyway. I'm gonna go ahead and do just some random int called, now let's do a bool on P, okay, for palindrome. I'm gonna set it equal, what should my default be here?
False.
Let's see, I'm going through the loop. No, I'll set it false if it's false. If not, I'm gonna leave it true. Okay, so this isn't done. This is good. I like this. I thought it was going to be just a kludge, as we call it, but it's not. It's going to be okay. Okay, so if I get to this point, then I can say P is equal to false. Okay. Now, what I don't like, and I'm not going to take the time to fix it, but what I don't like about this is that I'm going to go through the entire string even if it becomes false. And I really should put this in a while loop that I can break out of. Okay. But I'm not going to do that, at least not yet. Okay. So when I'm done with all of this, then I can say while P, and I don't need this here either. So while, no, not while P, if P. So if P is true, see out palindrome else not palindrome.
You already had it doing that.
I had the not, but it was in the wrong spot. Okay. So yeah, I don't like that it's going to take longer, but this should be okay. Okay. Let's try it. How bad can it be? Oh, it can be bad. Oh, anybody know the issue there? That is correct. Is that where it was? Because I could do it more than once. Okay, looks okay. Okay, does that mean we're working? No, it may always say it's palindrome. If I want to say something like race cars, not a palindrome. Okay, so I'm fairly confident that that is mostly working. Okay, but I think it's better here. So let me think about this. So if you want to replace this with a while instead of a for, you kind of have to add some stuff to it that it does for you. Okay, so I could say int count is equal to 0. And then here I would have to say while count is less than input size, and P. Okay, and P is true. Okay. Then I would have to make sure that in here at least I have to say count plus plus. Okay. I think I like that better, yes.
Instead of using a count, could you use like is empty queue?
Oh, I hadn't thought about that. Yeah, you could. You could have used either is empty queue or is empty stack, either one. That's better. Good for you. That's much less ugly. Okay, so I don't need the count at all. That's better. The count felt wrong. So while not is empty queue, well, there's an issue there. If we run out of one before the other, would we run out of one for the other? No, we couldn't. They're the same size. Yes, they are the same size. That's fine. And that's a function, right? Okay, I like it. Then we don't have to do anything with count at all. Did I still leave that count in there? I didn't. I got rid
Then
of it.
would you have to do all not queue period is empty queue, or could you just call it as empty queue? With your class, would you have to put the?
Oh, yeah.
So how
Yep.
do you know that they're the
Yep.
same size?
Because they're both the same size as the input string. If you have race car, you're putting one in both every time. And it's initialized when it starts, so there's nothing there. Okay? I think I like this. Race car works. Horses does not work. Okay?
I'm gonna see if it works with like a Y in the middle or something, like with just race car. Which it should work still. Like if you get what I mean?
I see what you're saying.
It's like if you had like a typo in spelling race car, it might run it through just because the engine. But
Yeah.
it doesn't.
Well, I wouldn't, yeah, it didn't matter the case. So what mine doesn't do that should have was deal with the cases, but it should be fine otherwise. Okay? But the main point of this is that I didn't create a stack or a queue, right? I just used them. So don't try to be creative. I have no type here. I have none of that stuff. I don't have to define the stack or the queue. I'm just pulling it in. Questions about this? Now, I don't know what happens on a palindrome if there is a space. I'm guessing you would need to delete the spaces. Do you remember when we did it before?
I don't think we did anything with spaces.
Okay, may not.
I think all we did was with, if it was lowercase or not.
Yeah, because I think if you do, yeah, so you would have to here say if input sub I does not equal, these are chars, single space. Okay, and then it's just is lower or two lower? That's two lower in C++.
Yeah, it's two lower.
It is two lower?
Yeah.
So input I is equal to input I dot two lower, is that right? Like that?
I think I put mine in, like in the parentheses. I don't remember for sure. It might be that.
Oh, I see what you're saying.
Yeah,
let's
I don't remember exactly.
Let's try it, see if it works.
Because
Nope.
I think I did two
Doesn't that
lower
have to be
I mean, or something like that. I remember that I had to fiddle with it for a little bit to get it to work.
Here's the quick way. Yep. So it's two lower. Yeah, I broke it. No. So now if I say, gotta run it, race car, it's boundary. So yeah, it works. Okay. So that's the iterative process that I would go through to solve that. Questions about any of that? Okay. Questions about anything? Okay. If you have questions this weekend, you can text me. Yeah, that's what you can do. That's the best bet.
Do you need me to be here on Monday since it's just a midterm?
Unless you want the money.
Yeah. I just don't see how I could be of much help.
Good. Okay, so that's all I've got. If you have more questions at some point, let me know.